So this part we want to see what happens when we put a conducting rod in a region with a magnetic field. So first let's see what happens when there's no magnetic field. So you just have a conducting rod and it's moving with a velocity v, and here I'm imagining one of the free charges inside the rod. Of course it's going to be moving then with the same velocity as the rod. They're all moving with a certain velocity v. So there's nothing going to happen to this charge. It's just going to be, there's not going to be a reason for it to go up or down in the rod. There's no force acting on it in this case. There's no net electric field at its location. There's no magnetic field at its location. So there's no force on it until now. But what if you come in this region and you apply a magnetic field into the page? Cross means into the page, and the rod is moving like this in the plane of the page with the velocity v. So what will the direction of the force be on this negative charge in this case? Well, the magnetic force is q v cross b. So v cross b is actually upwards. But because you have the charge is negative, so when you multiply by q, then the force is actually downwards then. So what's going to happen then is that these negative charges are going to start to move downwards. And after some time, some negative charge has accumulated on the bottom, which means that they left back in the top some positive charge remaining at the top. Now these charges, you have now an accumulation of positive charge here and negative charge here. What will those charges do? Those charges will make an electric field that goes from the positive to the negative. So this electric field pointing downwards, what kind of force does it apply on this negative charge? Is the force downwards or upwards? We know the force on a charge, the electric force is Q times E. So if the electric field is downwards and the charge is negative, then the force will be opposite the electric field, so it'll be upwards. So still at this point, the magnetic force is bigger than the electric force at this point in time, and so still more charge can accumulate in the bottom. But the more charge you put at the bottom, the more charge accumulates at the top, the stronger the electric force becomes. At some point they're going to equal each other, and when they equal each other, these charges in the middle are not going to want to move up or down anymore. They're just going to stay as they are. And this happens when the electric force QE is equal to the magnetic force QVB. The Q's will cancel, so you can just get a relationship then for the electric field in terms of the speed of the rod and the magnetic field. Now this is the electric field, then it's V times B. Every single point on this rod has the same speed, so V is the same, and the magnetic field is uniform, so the electric field is the same, has the same value all along the rod. So of course the electric field goes from a region of high potential to a region of low potential. So point A over here is at a high potential, point B is at a lower potential. So get the potential difference between A and B, VA minus VB. Well, since the electric field is just constant, we can just get the electric field and multiply by the length of the rod. So this is what the potential difference is between the two ends. And the electric field, we can substitute the VB, and so you get this result for the potential difference across the ends of the rod. So what happens when you put a conducting rod in a magnetic field, it'll induce charges on the ends of the rods, which will make a potential difference across the ends of the rods with a value BLV for this particular geometry. So basically, when you have a rod then moving in space with a certain velocity in this particular way, it acts as if it's like a battery. It acts as if it's like a positive side of the battery on the top and the negative on the bottom, so the top is higher potential than the bottom by a value BLV. So this is how we can use this then. We're going to use this in a circuit. What if you put this rod in a circuit, in a closed circuit? Then you can basically establish a current. So it's one way you can generate electricity. So we'll discuss this next.